Why today voice is breaking? I don't know. Fan, I will reduce the speed. Okay. Am I audible now?
Ma'am.
Yes, ma'am. Yes, ma'am.
Yes,
I
ma'am.
reduce the speed of fan, maybe because of that. Okay, so we will start with the next topic. So yesterday we learned the mechanism of polymerization of ethene, isn't it? And today I told you, when I taught you, there are two types of polythene. Polythene is formed by the polymerization of ethene, isn't it? Low density polythene and high density polythene. So the question they will ask you to write about both or any. Okay. So sometimes they ask you to distinguish between low density polythene and high density polythene. So first thing you have to remember is low density polythene are branched. They are branched, and high density polythene, they are linear polymers. So since they are linear, in the case of high density polythene, so they can be packed more. So the density is more. You understood? Got the point? You can remember like that. Low density, they are branched. Branched one, it is not that easy to pack come close together, isn't it? So density is less. That is the first point. Second point is the method of preparation. So method of preparation conditions are there. It is the monomer is ethene, but both cases, high density and low density polythene, the conditions are different. Conditions are different. So we will first see low density polythene. Low density polythene, it is a polymerization in presence of peroxide catalyst or dioxygen, and the temperature and high pressure 1000 to 2000 atmosphere, and the temperature is 350 to 570 Kelvin. So three things: temperature, pressure, and catalyst. Temperature is 530. Temperature is 350 to 570 Kelvin. Pressure is 1000 to 2000 atmosphere, and the catalyst is peroxide. Any one you say. And then now the polymers are starting. Each polymer method of preparation with use. You have to take out some time and learn with use. That is one way of asking questions. Okay. So low density polythene, all of you understood? So it is prepared by the polymerization of ethene, catalyst peroxide, temperature 350 to 570 Kelvin, pressure 1000 to 2000 atmosphere. And the main thing I told you, they are branched polymers. Because of that, density is less. Now coming to the uses. They are used, see, low density, their polythene is chemically inert, and they are poor conductor of electricity. So they are used in the insulation of electricity carrying wires. So that is another question. Which polymer is used in insulating wires carrying electricity? This much clear? So you can, it is, everything is given in the book. You read from the book and learn. You have to learn with the uses. It is not very easy to learn the uses because so many are there. So many uses.
We have to learn this
Ma'am,
temperature and
repeat that
pressure also,
question.
ma'am,
Uh,
for preparing.
yes.
Okay,
Conditions
ma'am.
are required. Okay. High
Okay, ma'am.
density means low temperature and pressure is also comparatively less. And the catalyst is there, it was peroxide catalyst. Here it is Ziegler-Natta catalyst. That is the name of the catalyst. And the Ziegler-Natta catalyst is a mixture of triethyl aluminum and titanium tetrachloride. So if for competitive exams and all, sometimes they ask you Ziegler-Natta catalyst. It is a combination. It is a mixture of triethyl aluminum and titanium tetrachloride. So if you don't want to write that, then also okay, Ziegler-Natta catalyst you write, and the temperature and the pressure is less 6 to 7, and the temperature is 333 to 343, not till 570 Kelvin. In the previous case, it was still 570 Kelvin, isn't it? And the low density, it is used in, I said, the insulation of electricity carrying wires and in squeeze bottles and toys and flexible pipes. And this one, high density polythene, this is also chemically inert, and they are used in the making buckets, dustbin, bottles, pipes, etc. So sometimes they ask you which polymer is used in making buckets. Okay, so it is high density polythene. Clear this much?
Yes, ma'am.
So you have to take out some time and learn, and tomorrow I will be asking. Okay, so that is 2 polymers we learned, and then these are all addition polymers or condensation polymers. They are addition polymers, isn't it? Polythene is addition. So here we are going to learn some more addition polymers. So the next,
So we can say high density polymers are high density polythene is more brittle, ma'am. Can we say that?
brittle.
Yeah.
Because squeeze bottles and toys and flexible pipes, they are saying low density polythene, isn't it?
Yes, ma'am.
So they are high. You can don't say that what is there in the book, that only you say. They are chemically inert, they are saying, and then why they are having high density due to close packing, and they are tough and hard. Okay.
Okay, ma'am.
So specifically take each polymer and learn. Okay.
Fine, ma'am.
So the next one is Teflon. Teflon, you heard about Teflon? Teflon coating, you must have heard in cookwares, isn't it? Non-stick cookwares, Teflon coating. Have you heard about that? So
Yes, ma'am.
next one is Teflon. Teflon is used in non-stick cookware. So I told you the use first itself. So Teflon, I have to come to the board. I'll come to the board. So Teflon. So Teflon is polymer AC. Which compound is this? Which compound is this?
Ethene.
Ethene. So if the hydrogen atoms are replaced by fluorine, what is the name? Tetrafluoroethene. So this is the monomer. N times tetrafluoroethene. So this polymerizes. Conditions are there. I will say here the catalyst is persulfate catalyst, not the peroxide. Now the conditions I will say, and then now how to write the polymer, I told you now we will remove the double bond and put N times. So this is Teflon. Can you see? So the monomer you will write. Monomer, if you don't remember, ethene, and all the 4 hydrogen atoms are replaced by fluorine. So tetrafluoroethene is the monomer. And how to write the polymer? You will remove the double bond, put a single bond, and N times. Any doubt on this? Okay. So this I told you the condition is the catalyst is persulfate catalyst. You can remember like that also because too many catalysts. In the case of low density polythene, it is the catalyst is peroxide. High density polythene, it is Ziegler-Natta catalyst. And Teflon, it is persulfate catalyst. And the next one is polyacrylonitrile, the first one. It is again peroxide catalyst. Like that you can learn. Okay. What is catalyst? Where, Ajay? Persulfate catalyst. Persulfate. And the next one is polyacrylonitrile. So again I will come to the board. Next polymer. So acrylonitrile is CH2 double bond CHCl. Both are from ethene. Ethene is CH2 double bond CH2. One H is replaced by Cl. This is acrylonitrile. Acrylonitrile. So N times. So how to write the polymer? I put that CH up. CH I put up. And so I will remove the double bond CH and Cn N times. This is how we write the polymers. Clear?
Ma'am, can you explain that again?
The monomer is acrylonitrile. Acrylonitrile again from ethene. Ethene is CH2 double bond CH2. One H of ethene is replaced by Cn. That is the monomer. So N times. How to write the polymer? We will remove the double bond. I put it as a single bond. Cn is up only N times. Okay?
Okay, got it, ma'am.
Yes, ma'am.
Okay. So these are addition polymers, and here polyacrylonitrile use. One more question once asked. This is used as a substitute for wool in making commercial fibers such as Orlon or acrylan. The question was, which polymer is used in Orlon? Got it? How the questions are coming? Have you understood? So polyacrylonitrile, that is, so the use is very important. So it is used as a substitute for wool. And so in fibers like Orlon and acrylan, underline and learn that. Okay, here I told you the catalyst is a peroxide. So we learned 4 addition polymers: low density polymer, low density polythene, high density polythene, Teflon, and polyacrylonitrile. Clear? And how many of you are keeping a book and writing down the equations? All of you do that. Anybody is doing that, keeping a book and writing? Keep a rough book and write. Very good. Good. Prashant, Kirtana, Akhila, all are writing. Good. Very good. Jay, writing. Good, Jay. Good effort. Chinmaya. Okay. Others also do that. Okay. Ruchi, Amitabh, Arbas. Writing. Good, Arbas. And what about Anand? Anand? Do you have a pen or a pencil with you? Tomorrow, bring a book and write, okay? So, organic equations you have to write. And then when I repeat, that is how you learn in the class. You remember how I make you learn equations. You do that, okay? Then I say, and then when the difficult equations are coming, I will give you time to learn, and then you write. For that, book is required, okay? Okay. The addition polymers we learned. Now we will learn examples of condensation polymers. And who can tell me fast another name for condensation polymer? Let me see who. Don't see the.
Ma'am, gap growth.
Step growth.
Polymers. Good, Varsha. So now we will go to condensation polymers, and the condensation polymers here, the addition polymers equations were very easy, isn't it? So you just have to remember that ethene, Teflon means all the hydrogen atoms are replaced by fluorine, and acrylonitrile, only one hydrogen is replaced by CN. If you remember the monomer, writing the polymer was very easy. But in condensation polymers, you have to remember the monomers. There will be bifunctional monomers, isn't it? And another question, children. Uh, so, copolymers, I said, copolymers are possible in addition reactions or condensation reactions. Tell me first. Copolymer.
Ma'am, your voice broke off there. Can you repeat, ma'am?
Copolymers are possible in condensation or in addition polymers.
In both.
Addition polymers, ma'am.
No, both ways they are possible. Addition, condensation definitely, different monomers will be there, isn't it? In addition also it is possible. When we learn synthetic rubber, you will get an example. Okay? Clear?
Ma'am, but they have mentioned as the part of copolymers
that
definition
is why I
that
asked you the question. They have mentioned in addition polymers, isn't it? But you learned
ma'am.
nylon 66, na Vishnu Priya? Who is this?
Chinmaya, ma'am.
Chinmaya, nylon 66. We learned nylon 66. What are the monomers? Say fast. Nylon 66. And any smart
Ma'am, NH.
No, I want the name. Names of the monomers. Monomers of nylon 66. Who can say?
Hexamethylene diamine and adipic acid.
That is it. You have to learn, children. So in this chapter, the majority of the question, they are asking, this time also, they give a polymer and ask you to write the monomer. That is the very frequently asked question. Very frequently asked question. So the monomers, you should be fast is like now Anand said, Vishnu Priya said, you have to say fast. And for that, every day you have to learn. Okay. And so condensation polymers, we will take one, see condensation polymers, we have polyamides, that one we learned nylon 66. It is an amide. You remember the hexamethylene diamine and adipic acid. And the joining linkage was C double bond ONH. Remember? In nylon 66, you remember? H of NH2 and OH of carboxylic acid was removed and water was eliminated. So the bond between the two NHCO. So NHCO is an amide bond. So nylon 66 is an example of a polyamide. So polyesters are also there. Polyesters, polyamides. So condensation, polymerization, they have given nylon 66, nylon 6. Both are polyamides. And a polyester, that is terylene. Have you heard about terylene? Terylene. And another one, four condensation polymers are there. One is nylon 66, nylon 6 is the second one. Then is terylene, which is a polyester. And then is a phenol formaldehyde polymer, that is bakelite. Have you heard about bakelite? We learned in the examples, isn't it? One more is there, melamine formaldehyde polymer. So 5 condensation polymers. Clear this much? And now I want you to write in the book when you will, it is condensation little difficult. You learn now itself. I will give you little time. And first I will explain nylon 66. Already you learned. I am not taking that again. And nylon 6. Nylon 6 I will do. So nylon 66 and nylon 6 are examples of what? Polyamide. polymers. They are polyamides. Okay. So I will go to the board for nylon 6. Nylon 6. Nylon 6, the monomer is caprolactam. So you have not heard about this. So you have to first you listen carefully and I will give you time. You can write the equation. Now caprolactam I am drawing. You see it is a polyamide. NHCO bond will be there. So first we will put a NH and it is six carbon atoms are there. When nylon 6 when I taught, I said, so 6 carbon atom means the sixth one is a CO because NHCO bond is there. So 5 you have to count and put 5 CH2. CH2, 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 C double bond O. Understood? Caprolactam? How to
Okay.
learn?
The camera little bit.
Clear?
A bit more, please.
And okay now?
Little more, ma'am.
A bit more, ma'am.
Nice, ma'am.
Okay. So caprolactam, all of you look here, you are going to learn. Caprolactam is the monomer. And I said there will be 5 CH2 group and the sixth one is a CO. So 6 carbon atom, that is why the name comes as nylon 6. So NH you will write and count and put 5 CH2. 1, 2, 3, 4, 5. Sixth one is a CO because this bonding is NH CO is the amide linkage. Amide linkage. So this is also a polyamide. Understood? So all of you write caprolactam and learn, then we will write. The polymer is easy. Caprolactam. If you are not able to understand the structure, tell me. Learn? Draw and learn caprolactam or nylon 6. Got it, children?
Done, ma'am.
So this on polymerization. I will write the polymer on top. Polymer is easy. So NH one side, CH2 5 times, C double bond on another side 10 times. This is nylon 6. Conditions are there. You have to add water at a high temperature. Temperature is 533 to 543 Kelvin. 533 to 543 Kelvin. 43 Kelvin. So write and learn nylon 6. Any doubt on this? You can put, say in the book they put a CO this side. You can put any side.
Done, ma'am.
Ma'am, I
Done?
think Prashant has a doubt.
What
I
Prashant?
think Prashant has a doubt, ma'am.
I'll see. Others write and practice. Let me see Prashant's doubt. Prashant. So this is the monomer, caprolactam. And how to do the write the caprolactam? NHCO bond will be there. So you start with NH. Can you see, Prashant? Start with NH, count and 5 CH2 group. CH2, 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 then CO. This is caprolactam. This is the monomer. And polymer means this is opening up. NH, then CH2 5 times, CO n times. This you have to learn by heart, the structure and the polymer.
Learned, ma'am.
Prashant, is it okay? So we learned 2 polyamides, nylon 6 and nylon 6. Nylon 6 I am not repeating again. Now we will learn polyesters. Terline, have you heard about terline? Where you heard? Where we use terline, terene? Where we, anybody heard about that? Terene, terline, synthetic clothes, isn't it? Terline, this cotton mixed with the synthetic fibers. So terline is a synthetic fiber. Okay. So it is a polyester. Terline is a polyester. So you can remember polyester means there should be an alcohol and a carboxylic acid. So in terline, glycol. Glycol is CH2OH, CH2OH. Two OH groups are there. And the carboxylic acid is terephthalic acid. Terephthalic acid. It is an aromatic acid with two CHCOOH group. This much clear? The monomers are glycol, ethylene glycol and terephthalic acid. Clear?
This is for terylene, right?
Terline only I am saying. It is a polyester. Terline, another name is dacron, DACRON. Sometimes they will ask you, how do you prepare dacron? So the names, terline, terene, dacron, all are the same. So the monomers name, ethylene glycol and terephthalic acid. This much clear? I have to go to the board. First monomers I will write, you learn by heart the monomer. Ethylene glycol, you know that. CH2OH, CH2OH, first monomer. Ethylene glycol. Terephthalic acid, benzene ring. One COOH group here. The second one at para position. This is called terephthalic acid. See, have you heard about phthalic acid? This is terephthalic pH. So first learn this. The monomers for terline, ethylene glycol and terephthalic acid. So n times this plus n times. Learn that. Temperature is high, 420 to 460 Kelvin. And the catalyst is zinc acetate, antimony trioxide. So the information I have written. Who is this? Why Shashank is coming so late? Why are you late, Shashank? Shashank, can you hear me? Others learn both the monomers. "45 minutes late. Why are you late, Shashank? What you will learn like this if you come? So the monomers learn, children. Ethylene glycol and
Antimony trioxide is SbO3. Am I right?
This is the catalyst. Sb2 will come. So the polymer, you learn the monomers. The polymer will be, you look here, H of glycol and OH of carboxylic acid. Water will be eliminated. This is a condensation polymer. So water will be eliminated. The water elimination is from H of glycol. That you should remember. Then only correctly you can write the polymer. Water elimination is from H of glycol and OH of COOH group. Have you understood? Now the polymer I am going to write. Okay. Now here this side CH2 CH2O. H I will not write because this side another terephthalic acid will come and CH2. Now here O is there and OH is removed, C double bond O, C double bond O N times. Have you understood? The polymer like that only. Here H of glycol.
Once more, ma'am, once more.
See, elimination, water elimination is H of glycol and OH of the acid part, next monomer. So, the same in the middle, so that is why in the middle it came as O, CO and it is connected. See here. And so, the end when we write the polymer, this H we will not write. Why? This side another polymer long chain, isn't it? Another terephthalic acid will come. And here I don't write OH. Here another glycol will come. So that is it. So H I removed, put O, remaining as such. You look here. CH2, CH2, O, CO, benzene ring, CO. This OH, another glycol will come. So I don't write this OH, I don't write, this H I don't write. And this water is eliminated. Clear?
Okay, ma'am, got it.
Yes, ma'am.
Okay, write 2-3 times. Anybody else not able to understand? Tell me. Others write and learn now itself. Terline or dacron. Temperature and catalyst I wrote on the board. Anybody else? Not understood? You want further explanation? Shashank, can you come switch on the video? Switch on your video. Others learn that. Shashank. Show the equation. Shashank, are you there? Done? Not able to understand the equation.
Ma'am, one doubt, ma'am.
Say.
Where is this H and H going, ma'am, in the last
See,
of the both
it is
monomers?
a polymer, no? This is only a dimer. What I wrote, if I put OH and COH, it will be a dimer only. Polymer means here, see, another terephthalic acid will come. So I cannot put H. Here also it is reacting and a long chain. Na? And here, in this, here, another glycol will come, for water will be, that is how it is a long chain polymer.
Okay, ma'am. So that H will go and attach to another.
We should know that which water is eliminated, water
Yes, ma'am.
H from where and OH from where. So
Okay.
H from glycol. So I cannot put H this side. And
Okay, ma'am.
OH from acid. And
Okay, ma'am. Understood now.
Prashant did not understand. Prashant, you have to first learn the monomers, glycol and terephthalic acid. Both will react. It is a condensation polymer. Water will be removed. So water removal is from H of glycol and OH of acid. So this is only a dimer. We are writing 1, but there are n number. It is a long chain. So you know that this water is removed, then you write the polymer. When you write the polymer, you know that this H, another terephthalic acid will come. So I remove that H and put a dash, enzymes. And the remaining CH2, CH2, O, CO, benzene ring, C double bond O. This OH I cannot write because another glycol will come. So this is the polymer. This is terylene or dacron. Now understood?
Yes, ma'am. Got it, ma'am.
Okay. So we learned this is little. If you do not practice, you will not get. Okay. So we learned nylon 6 and tell me, I will give you 2 minutes. How many of you can write nylon 6 and dacron fast and tell me how many you wrote without seeing. Nylon 6 and dacron. Okay. And let me see. After writing, you tell me. Still, Shashank not here? You joined now. Where are you, Shashank? Shashank, are you here? Saurabh, very good. First, Saurabh came first. Shashank, why are you not answering me? You switch on your mic and video. I want to see you. At least type if you are there. Why are you coming late every day? I want to know. Good, good children. Varsha done. Abhishek done. Very good, Abhishek. Ruchi done. Ajay, what is the catalyst for? Catalyst only I wrote on the board. Zinc acetate and antimony trioxide. Ajay, that is the catalyst. Zinc acetate and antimony trioxide. What about Agnel and Jay? Jay, have you written? And Bharati, where are you? Done. Okay. Arbas done. Where is Jay and Agnel?
I'm here, ma'am, writing.
Writing. Okay. Agnel also complete. So because it is required, now more polymers are coming.
Ma'am,
Ask.
for nylon 66, there are two equations, ma'am. One in page number 439 and one more.
Same only. Both are same only.
Can we write any of them, ma'am?
Both are the same, no?
Okay.
Any one you can write. Okay?
Okay.
So, why Shashank is not, you have to respond to me, Shashank. Why are you not listening, or you just kept the phone and went somewhere? I want to know what is happening. Strange it is. Okay, so we learned the condensation polymers, nylon 66, nylon 6, and dacron. Okay, good, smart children. You wrote that. So now the next one is bakelite. Bakelite is a phenol formaldehyde. This year also they asked, what is the polymer, monomer of bakelite? So, okay, so bakelite, it is a phenol formaldehyde polymer. Phenol and formaldehyde. And so first it will react and you will get an intermediate called novalac. Novalac is used in paints. And the novalac again with the phenol and heating, then you get bakelite. It is a cross-linked polymer of cross-linked. You learned in the first classification, cross-linked polymer. So bakelite is a cross-linked polymer of phenol and formaldehyde. Clear? So it is first an intermediate will be formed, and then which is again heating with the formaldehyde, you will get a bakelite. Clear? Now I will go to the board. So phenol and formaldehyde. Formaldehyde is HCHO, right? So here instead of that they are just writing CH2O. It is HCHO only. Formaldehyde. So this will react and first you will get these compounds, a mixture of this. So this is hydroxymethyl phenol and so the monomers are phenol and formaldehyde. So you will get a mixture of this compounds. So at the ortho position CH2OH will come, and so this CH2OH is hydroxymethyl phenol, and the second in the para also it comes, and the third one is 2,4,6 trihydroxymethyl phenol. Clear? And so now this one, the first one undergoes polymerization and you will get a novalac. So we will take the first one. So this one, N times OH, CH2OH. This undergoes polymerization and I am going to write the polymer. Look here, OH, and this phenol is connected everywhere by CH2. CH2, OH, CH2, like that it is continuing. This is novalac. Understood? First novalac intermediate will be formed. So you will take the first one, ortho hydroxymethyl phenol, that undergoes polymerization and this will be formed. This is novalac. So you just write phenol and this, and that reacts with this. Okay? Now this on heating with the formaldehyde, cross-linking will take place and another polymer. This is only an intermediate. And the polymer is bakelite will be formed. Understood this much? Any doubt you can ask? Board is not visible. Now is it okay? Can you see the board, Ajay?
Ma'am, can you repeat once again, ma'am, briefly the
Yeah,
few
I
things?
will repeat. Board is, can you see Ajay board? Okay. Others can see the board?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So I will repeat. The monomers are phenol and formaldehyde. Don't say novolac. If bakelite is asked, the monomers are phenol and formaldehyde. So phenol and formaldehyde, CH2O. So you will get OH, CH2OH plus OH and here CH2OH and 3 here also. Like that, 3 products will be formed. Out of that, the first one will polymerize, and the first one will polymerize, and the polymer is the novolac, which is an intermediate. And how to write that? That much only you will remember. Okay, how to write phenol? You know that on the benzene ring OH. So many phenols are connected by CH2. That way you can remember. So CH2 this way it will continue like this. And CH2 here again phenol CH2. This much only. Clear?
Yes, ma'am.
Understood? So this is intermediate novolac. And this novolac on heating with the formaldehyde, we will get bakelite. So now I am going to draw the structure of bakelite. Anybody, any more explanation required? Ask now. I am going to rub it off. Anybody needs any explanation? Can I draw the bakelite?
Yeah, ma'am.
Yes, ma'am.
Ajay? Could you see? Okay, now I am going to draw bakelite. Okay, bakelite only the structure. How to draw I will say. What novolac you remember now? OH connected by CH2, CH2, OH connected by CH2 going on. And here and here you put the CH2 connected by phenol. OH down, here CH2, here CH2, here connect by phenol, OH down, and the CH2 is here. Yeah. Here CH2. This is bakelite. Understood?
Yes, ma'am.
Only that phenol here you have to remember that the second phenol is down OH and connected by everywhere connected by CH2. You draw 2-3 times, you will get a draw now. And meanwhile, anybody else want further explanation? I will explain.
Ma'am,
Yes.
how
Yes.
I didn't understand in this bakelite, ma'am. How is
Ah.
the two CH2 molecules coming in between the novolac compounds?
No, it is elimination will take place. It is a condensation polymer, no?
Hmm. No, ma'am. If we see like that, it is just two
Ah.
novalax are there, and in between a
No, no. You may be
CH2 is there.
thinking water eliminate, one more oxygen will be there. Like that you are thinking. But this reaction takes place in presence of an acid or a base. So this
Okay,
only
ma'am.
will happen. Okay. Conditions are there. And this is taking place in presence of an acid or a base catalyst. So
Okay,
you
ma'am.
just have to learn like that. The structure you will learn, the monomer you will learn, novalac is the intermediate. And then cross-linking.
Fine, ma'am.
Okay.
Yes.
So if you have you learned, then next one we will learn melamine. Have you all learned bakelite?
Yes.
Others? Okay. So we will move ahead with the melamine formaldehyde polymer. So here also little bit of learning by heart. So these polymers, they are actually easy, but a little learning by heart is there. So I will, next one is melamine. Have you heard about melamine? Where you, what use? Melamine cookware. Unbreakable plates and all, na? They are made up of melamine, isn't it? So melamine formaldehyde polymer. So here also there is an intermediate like novalac resin intermediate is there, then polymerization. Okay, so melamine resin, melamine polymer. So use is easy only. Unbreakable crockeries, unbreakable cups, unbreakable plates. They are made up of this melamine polymer. So melamine formaldehyde polymer. Okay. So melamine, first melamine and formaldehyde. Melamine I am going to draw. Listen carefully. Benzene ring, alternate double bond, and alternate nitrogen. See, here nitrogen, here nothing. Here nitrogen, here no. Here nitrogen. Alternate nitrogen I put, and then where nitrogen is not there, there NH2. NH2, NH2. Got it? This is melamine plus formaldehyde. All of you learn melamine structure. How to learn? Benzene ring, alternate nitrogen, double bond, and where nitrogen is not there, there NH2. Got it? So I said there is an intermediate, resin intermediate. I am going to draw that. So alternate nitrogen. Where nitrogen is not there, NH2, NH2 here, NH, CH2, OH. This is resin. So this much you write and learn. Right, and any doubt you can ask. Done, children?
Yes, ma'am.
Others?
Yes,
Ma'am,
ma'am.
that NHCH2OH part that on the resin, ma'am, I am not a bit clear.
No.
How is that?
This is CH2O. This H and this NH, CH2OH.
Okay, ma'am.
Okay.
Yes, ma'am, got it.
Others, anybody else? I am going to rub this off. Children? Good, Ajay. Varsha, good. Akila, done. And this much clear, children. This is resin. And now this intermediate will polymerize and you will get the polymer. So again come to the board. Now the polymer, and you know that water elimination will be OH off and NH, H off. So everywhere H will be removed and there CH2. That is the polymer. So I am going to draw the polymer. Here I will put only NH. Here I will put only NH. Here I will put NH CH2 n times. Understood?
Ma'am, could you explain this concept?
Here, this is the intermediate resin. The polymer, the changes you should know, isn't it? Water elimination will happen. Here, this side, another resin will come and it's CH2OH there. This and OH, water will be eliminated. So wherever NH2, I will put NH because here another resin will come. Here another will come. And here what happens in this? Here NH of another resin and OH. So these are the, here are the water eliminations, isn't it? So I have to write like NH, H is removed, here H is removed, and here OH is removed. Got it?
Got it, ma'am.
So write, children. Write and learn. Novalac, I'm sorry, melamine,
So,
formaldehyde.
ma'am, from NH to 1H is going, and from NHCH CH to OH,
Everywhere,
the OH
every
part is
side,
going.
here another one will come. Another one comes means this OH part will come. Water will
Okay,
be
ma'am, got it.
here also another. Polymer means a large number, na? And
Okay,
here NH of NH2 part will come. So
all right,
everywhere we will remove. Here OH we will remove. Every NH2 part H we will remove. Okay?
yeah, ma'am.
Now. Now I want you to write whatever polymers I am going. Good children. So now I want you to write nylon 66, nylon 6, dacron, bakelite, and melamine. 5. If you write, I will be very happy. I want to see who writes first. 5. Write it now. And you have to tell me. Some children are not responding at all.
Ma'am, can you please repeat which and all?
What we learned, nylon 66, see na, polyamide, condensation polymers. I'm not asking for Teflon and acrylonitrate. Only condensation polymers. Nylon 66, nylon 6, terylene or dacron, bakelite, melamine, formaldehyde, polymer. This much. Do fast and then write. Okay, if you learn means it is 50%, only 50% of learning. You have to, after the class, practice. Okay. And after you finish, tell me how many you have done. Very good. Anand. Oh. Varshini, good Varshini, Varsha, smart children, Kirtana, Abhishek, good, Chinmaya. So majority of the children have done. I can take little more. Okay, good. And today after the class, sit for some time and practice the polymers. And then another thing, uses you have to learn. Okay, some uses you know that. Like I said, melamine, it is in unbreakable the cookware, isn't it? And Teflon, non-stick. So others also you learn. Okay, Vishnu Priya. Okay. So we will learn little more, and at least the rubber part I will explain. It is okay. 2 minutes. Rubber we will take tomorrow. Okay. So any doubt you can ask? Doubt?